Hello my friend, welcome to my channel. So today we are going to graph a rational function. So the rational function is y equals x plus 1 divided by 2x squared plus 5x minus 3. So as you can see, the degree of the numerator is just 1 and the degree of the denominator is 2, right? Okay, so let's find the domain of this function. To find the domain, you have to look at the denominator, right? So it is a quadratic function. Let's first find the factors of this 2x square plus 5x minus 3. What are the factors of this one? There are two factors. So here 2x square, so I need 2x and x. And here negative 3, that is 3 times 1. It is a negative number, and look at the linear term, it is positive 5, so that means I should have positive for 3 and negative for 1. So this gives you 2x square, 2x times 3, 6x, and negative x, which is 5x, right? Okay, and then negative 1 times positive 3 is negative 3. These are the factors. Okay, so then you can write down your y equals x plus 1 over 2x minus 1 times x plus 3. So this is your rational function, right? So let's find the domain. To find the domain, you have to look at the denominator and you have to find all the x values that make the denominator equals 0. So consider the first factor, which is 2x minus 1 equals 0. Then solve for x. It gives you x equals positive half, right? If you solve for x, this one, x equals half. And the other factor, x plus 3 equals 0. Then x equals negative 3. So you have to remove x equals negative 3 and x equals half from your domain. So that is, your domain should be negative infinity to negative 3 open parenthesis union negative 3 to the positive half open union half times positive infinity. So this is your domain. So it is like this in the real line. So you have half, right? And here you have negative 3, so you have to remove these two, and then you have to consider this portion, and this portion. So that's why we take union of these three sets. Okay, so make sure to have open parenthesis for half and negative 3 like this. Okay, so that's the domain. Let's find the x-intercept. How do you find the x-intercept? So at x-intercept, you know y value equals 0, right? So to y, if y equals 0, then this term should be equal 0, then we can have y equals 0, right? So that means x plus 1 equals 0, then y equals 0. So then solve for x, which is x equals negative 1. So that means your x-intercept coordinate is negative 1, 0. At x equals negative 1, this term becomes 0. Then that is y equals 0. And how do you find the y-intercept? At y-intercept, x value is 0. So substitute 0 for x. So I'm going to use this form. 2 times 0 minus 1 times 0 plus 3. So if you solve for this one, you get what? Here 1. 2 times 0, 0, negative 1, positive 3. Negative 3, right? So multiplication, negative 1 times 3. So negative 1 over 3. So y-intercept then is 0, negative 1 over 3, right? And then let's look at the vertical asymptote. To find the vertical asymptote, you have to look at the denominator and find the x values that makes the denominator 0. So here we consider the factors like this, and we found these x equals negative 3. So x equals half can be your vertical asymptote, and as well as x equals negative 3 is another asymptote. So you have two vertical asymptote here. So at these points x equals half, your numerator is not equal 0, right? Half plus 1 is 1.5, right? And x equals negative 3, your numerator value is negative 2. So it's not 0, but at these points your denominator 0. So these two are vertical asymptotes. Then look at the horizontal asymptote. If you look at this rational function, you can see the degree of the numerator is 1 and the degree of the denominator is 2. So degree of the denominator is higher than the degree of the numerator. So in that situation, your vertical the horizontal asymptote becomes y equals 0. Why? Because the degree of the numerator less than the degree of the denominator. In this situation, right, your horizontal asymptote is y equals 0, which is the x-axis. Y equals 0 means the x-axis, right? Okay, so now we have everything. Now let's graph this rational function. First you have to mark the horizontal asymptote and the vertical asymptote. As you can see, vertical asymptote is x equals half. So it is over here. So here you have 1, right? Here you have 1. So x equals half is a vertical asymptote. Okay, like this. And another vertical asymptote at x equals 3. So you have another vertical asymptote, right? And your horizontal asymptote is y equals 0, which is the x-axis. So this is your x equals negative 3 vertical asymptote, and this is your x equals half, another vertical asymptote, right? And this x-axis is your horizontal asymptote, which is y equals 0, right? The horizontal asymptote. Now let's mark the x-intercept. X-intercept was negative 1, 0. It's over here, right? And the other one is y-intercept is 0, negative 1/3. It's like over here, right? Okay, so now you can graph, but sometimes we need another points to look at the shape of this graph. So x equals half is a vertical asymptote. You know this graph is like this, right? So if the shape like this, then it goes down to negative infinity, right? And this side from left, it goes to negative infinity at this vertical asymptote, and then from right it goes to positive infinity, and it goes down. Since this is a horizontal asymptote, it goes like this. Okay, and let's look at this side. Here this graph can be go like this or go like this, right? Both way, right? Go like this or go like this, but we have to find another point. Let's look at x equals 2. What's the value? If it is positive, then your graph go like this. Okay, if it is negative, your graph go like this. Let's substitute x equals negative 2 to the function, right? Look at the value. At x equals 2, y value is 2 plus 1 over 2 times 2 minus 1. Here negative 2, okay? Negative 2, substitute negative 2 times negative 2 plus 3. So this is negative 1 over negative 2 times 2 is negative 4, negative 1, negative 5 times this one is what? Negative is positive 1, right? Okay, that means 1 over 5. So it's a positive number. At x equals to, your function value is 1 over 5. It's a positive number, right? So that means your graph go like this. So that means, so this is a vertical asymptote. It goes to positive infinity. Okay. Now this side from right, it goes to positive infinity. Then from left, it should goes to negative infinity, right? And then since this is the horizontal asymptote, this graph goes like this. Okay. So this is the graph of the rational function. We talk about x equals, so y equals x plus 1 over 2x squared plus 5x minus 3. So this is the graph. So you can confirm this graph if you use some software to graph this rational function. You will see the graph is like this. Okay. So I hope you understand. If you have any questions, please comment, and thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.